Imagine this. You're floating in space, millions of miles from Earth, and in front of you, there's something that shouldn't exist, a black hole. But it's not just sitting there quietly, it's spinning, faster than anything in the universe, and as it spins, it's dragging space itself around it like a cosmic tornado, twisting reality, warping time, creating a vortex so powerful that if you got too close, you wouldn't just be pulled in, you'd be twisted, stretched, torn apart at the atomic level. This isn't science fiction, this is real. NASA confirmed it, Einstein predicted it, and what these cosmic tornadoes can do to time and space will fundamentally change how you understand reality itself. Now, before you think this is just another cool space fact, here's why this matters more than you realize. This isn't about black holes being scary monsters in space. This is about understanding that the universe doesn't work the way you think it does. Right now, as you're watching this, you think time moves at the same speed everywhere. You think space is just empty, a stage where things happen, but that's wrong. Black holes prove it. They don't just exist in space and time. They create it. They twist it. They control it. And here's the part that should terrify you. If you got close enough to one of these spinning black holes, time for you would slow down. Not because you're moving, but because space itself is being dragged. You could orbit a black hole for what feels like an hour, and when you came back, everyone you knew on Earth would be dead. Decades would have passed. That's not a metaphor. That's physics. This is about realizing that reality is far stranger, far more flexible, and far more dangerous than anything we experience on Earth. Let's start with what makes these cosmic tornadoes so mind-bending. First, you need to understand what a black hole actually is. Most people think it's a hole, like a pit in space. But that's not right. A black hole is a place where gravity is so strong that space itself collapses. Imagine taking the entire mass of the sun and compressing it down to the size of a city. Then keep compressing, smaller, denser, until all that mass is crushed into a point smaller than an atom, a singularity. At that point, gravity becomes so powerful that nothing can escape. Not light, not matter, not even information. The boundary around that singularity, the point of no return, is called the event horizon. Cross it, and you're gone forever. But here's what most people don't know. Black holes don't just pull things in, they spin. And when they spin, they create something far more terrifying than just gravity. The fastest spinning black hole we've ever detected is called GRS 1915+105. It's located about 35,000 light years from Earth, and it's rotating at 950 times per second. Let me put that in perspective for you. The fastest human-made object, the Parker Solar Probe, travels at 430,000 miles per hour. Impressive, right? This black hole's edge is moving at 84% the speed of light. That's 568 million miles per hour. And as it spins, it doesn't just rotate, it drags space and time with it. Einstein called this frame dragging. Imagine space as a fabric. Now imagine a bowling ball sitting on that fabric, creating a dent. That's gravity. But now spin that bowling ball. The fabric around it starts to twist, spiral. That's frame dragging. Except with a black hole, it's not fabric. It's reality itself. So here's the question nobody asks when they hear about spinning black holes. What actually happens to space when it gets dragged like that? Does it just bend? Does it break? And what does that mean for anything caught in it? The answer is going to mess with your head, because space doesn't just bend, it creates something called the ergosphere. This is a region outside the event horizon where space itself is being dragged so violently that nothing can stay still. Even if you fired your rockets at full power in the opposite direction, you'd still be pulled around the black hole. Not into it, around it. You'd be forced to spin with space-time itself, like being caught in a cosmic whirlpool. And here's the terrifying part. Time inside the ergosphere doesn't work normally. The closer you get to the black hole, the slower time moves for you. From your perspective, everything feels normal. But to an outside observer watching you, you'd be moving in slow motion, speaking in slow motion, aging in slow motion. NASA proved this happens. In 2004, they launched a satellite called Gravity Probe B. Its mission was to measure frame dragging around Earth, a planet that barely warps spacetime compared to a black hole, and even Earth, spinning once every 24 hours, dragged space around it by 37 milliarc seconds per year. That's a measurement so small it's almost undetectable, but it's there. Now scale that up to a black hole, spinning 950 times per second. The frame dragging isn't milliarc seconds, it's massive. Space is twisted into a violent spiral, a cosmic tornado made of space-time itself. But here's what really makes this insane. These tornadoes don't just twist space, they twist time. Let me explain with a thought experiment. Imagine you and your twin are astronauts. You get in a spaceship and fly close to a spinning black hole. You enter the ergosphere and orbit for what feels like 1 hour. Then you leave and return to Earth. When you land, your twin is there waiting. Except they're not your age anymore. They're 50 years older. You've aged 1 hour. They've aged 50 years. This isn't theory. This is what Einstein's equations predict. Time dilation near a black hole is so extreme that you could use it as a time machine, not to go back, but to go forward. You could skip decades, centuries, millennia, just by getting close enough and coming back. Except here's the problem, you can't come back. Because the gravity is so strong, the fuel required to escape would be more than any rocket could carry. Now let's talk about what happens if you actually fall into one of these cosmic tornadoes. And this is where it gets truly horrifying. As you approach the event horizon, tidal forces start to rip you apart. Gravity at your feet is stronger than gravity at your head. You start to stretch, slowly at first, then faster. Your body elongates, your bones crack, your organs compress. Scientists call this spaghettification. You're literally turned into a noodle. But with a spinning black hole, it's worse, because you're not just being stretched, you're being twisted. The frame dragging torques your body, spirals you, wrings you out like a wet towel. By the time you cross the event horizon, you're not recognizable as human anymore. You're a stream of atoms spiraling into oblivion. But here's the question that keeps physicists up at night. What happens to those atoms once they cross the event horizon? Do they just vanish? Do they get crushed into the singularity? Or does something else happen? The truth is, we don't know. Because once something crosses the event horizon, information about it is lost forever. This violates one of the fundamental principles of physics. Information can't be destroyed, it has to go somewhere, but black holes seem to delete it. Stephen Hawking spent decades trying to solve this. He proposed that black holes slowly evaporate through Hawking radiation. That information escapes over trillions of years. But even he admitted we don't fully understand it. So when you fall into a black hole, you don't just die. You disappear from reality. Your atoms, your energy, your entire existence, erased. If that makes you realize that the universe operates on rules so far beyond human comprehension that even our greatest minds can't fully explain them, hit that like button. Because black holes aren't just objects in space. They're proof that reality is far weirder and far more dangerous than we ever imagined. Now here's where this story gets even stranger, because these cosmic tornadoes don't just destroy, they create. When matter spirals into a black hole, it forms an accretion disk, a swirling disk of gas, dust, and debris orbiting at near light speed. Friction heats this material to millions of degrees, so hot that it glows. X-rays, gamma rays, visible light. Some of the brightest objects in the universe aren't stars. They're black holes feeding. And as material spirals inward, some of it doesn't fall in. It gets ejected, shot out in powerful jets from the poles of the black hole. These jets travel at 99% the speed of light and extend for thousands of light years. They're so energetic they can sterilize entire galaxies. If one of these jets pointed at Earth, it would strip away our atmosphere in seconds. But here's what blows my mind. These jets might be responsible for life. Wait, what? How can something that destroys also create? Here's the theory. When black hole jets plow through interstellar gas clouds, they compress them. That compression triggers star formation. New stars ignite, planets form, and on some of those planets, conditions become right for life. Without black holes, without their violent jets, star formation in the universe would be slower. Fewer stars means fewer planets, fewer chances for life. So in a twisted way, the most destructive force in the universe might also be responsible for creating the conditions that allowed you to exist. Let me put this in perspective for you. The supermassive black hole at the center of our galaxy, Sagittarius A star, has a mass of 4 million suns, and it's spinning, right now, creating a cosmic tornado 27,000 light years from where you're sitting. It's pulling in gas, warping space-time, dragging reality itself into a spiral. And here's the crazy part. It's relatively quiet. It's not feeding aggressively. But billions of years ago, it was. It shot jets across the galaxy. It lit up the Milky Way like a cosmic lighthouse. And those jets shaped our galaxy, pushed gas, triggered star formation, created the conditions that led to our solar system, to Earth, to you. You exist because of a cosmic tornado created by a black hole. Now here's the question that really messes with physicists. If black holes can twist space and time this violently, what else can they do? Could you use them to travel faster than light? Could you use them to create wormholes, shortcuts through space-time? In 1988, physicist Kip Thorne proposed that a rapidly spinning black hole might create a stable wormhole, a tunnel through space-time connecting two distant points. You could enter near one black hole and exit near another, light years away, instantly. It's pure theory. We've never seen a wormhole, but the math says it's possible. And if it is, these cosmic tornadoes aren't just destructive forces. They're gateways, portals to other parts of the universe, maybe even other universes. But here's the catch. To stabilize a wormhole, you'd need exotic matter, matter with negative mass. And we don't know if that even exists. Without it, any wormhole would collapse the instant you tried to use it. You'd be crushed into a singularity before you made it through. So while black holes might theoretically allow faster than light travel, practically, they're still just cosmic death traps. Beautiful, fascinating, absolutely lethal. So what does this mean for you? For us living in 2025, it means we're living in a universe that's far more dynamic, far more violent, and far more strange than we ever imagined. Black holes aren't just endpoints, they're engines. They shape galaxies, they control star formation, they might even be connected to the birth of the universe itself. Some scientists think our entire universe could be inside a black hole, that the Big Bang was actually matter falling through an event horizon from a parent universe. We're living inside a cosmic tornado that spawned 13.8 billion years ago. And if that's true, then reality as we know it is just one layer in an infinite structure of nested black holes, universes within universes, tornadoes within tornadoes. But here's where this story takes a turn you won't see coming. Because while black holes twist space and time in ways we're only beginning to understand, there's something else out there. Something even more mysterious. Something that makes black holes look simple by comparison. Dark energy, the force that's not just bending space, it's tearing it apart. Right now, the universe is expanding, faster and faster. Galaxies are flying away from each other, and scientists have no idea why. They call the cause dark energy, but that's just a placeholder name. We don't know what it is. We don't know where it comes from. And here's the terrifying part. It makes up 68% of the universe. Black holes? They're only about 0.1%. So while we're studying cosmic tornadoes that twist reality, there's a force out there that's ripping reality apart, and we don't understand it at all. What happens when that force wins? What happens when space expands so fast that galaxies can't hold together, that stars can't form, that atoms themselves get torn apart? That's a question for another time. For now, just remember this. Right now, 27,000 light years away, there's a cosmic tornado spinning at the center of our galaxy. It's dragging space, twisting time, creating jets, shaping reality, and everything you are, everything you've ever known, exists because that tornado has been spinning for billions of years. You're not separate from black holes. You're a product of them. And when you look up at the night sky and see the stars, remember this. Between those stars, in the darkest parts of space, there are tornadoes, cosmic tornadoes, spinning faster than anything you can imagine, twisting the very fabric of existence. And if you could survive long enough to get close to one, you'd see something no human has ever seen. The edge of reality itself, bent, twisted, torn. A glimpse of what the universe really is beneath the calm surface we call normal. And it's beautiful, and it's terrifying, and it's waiting.